Yes, welcome to Module 5, Lesson 5, Chance Experiments with Outcomes that are not equally likely. Okay, yeah, so here we go. We'll get into the real heart and soul of our probability. Lots of fun, and this is just the beginning. They're going to have a few lessons concerning this, so this lesson should be quite quick as well. Okay, so here we go. Let's just get started. And this, they're making a point here, and the first point to be made is that in previous lessons we've learned that when the outcomes in a sample space, okay, and those are all the possible outcomes, are equally likely, the probability of an event is the number of outcomes in the event divided by the number of outcomes in the sample space. Okay, so for example, if we know that there were 20 different outcomes because there are 20 blocks in a, actually better to say this, if we had 4 different colors that were in a bag, they're all the same, equally likely. The chance of getting one of those 4 colors is 1 out of 4, because you could, if there were 20, then if they're all the same chance or same probability, there would be 5 of each. So 5 out of 20 is the same as 1 out of 4. Okay, so that's no longer the case. We're not going to be looking at examples like that. However, it goes on here in the red here. However, when the outcomes in a sample space are not equally likely, we need to take a different approach. And sounds so groundbreaking, but the truth is, it just makes a lot of sense, and it is still very similar. And we'll see that, I guess, in future lessons, but let's see where they take us here. Okay, so example 1, when Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table below. This is really a silly example, but I mean, you can learn something about how to express probability, but still silly. I mean, I never think of a probability of my getting bananas, or how many bananas I'll get when I go anywhere. Weird. But anyway, let's go with it, okay? So here you go. Here's a table, and she's made that up. Number of bananas, you can see 0, 1, 2, 3, 4, 5, and the probability of her buying that number of bananas. Like I said, weird. Anyway, what is the probability that Jenna buys exactly 3 bananas? Well, if we go ahead and look in that 3 banana column there, we see that it's 0.2 or 20%. So why don't you, because this is pretty easy, would you go ahead and do B, C, D, and E and come on back? You may trip on one of those, I'm not sure, but come on back after you do them. Okay, you're back. Let's go ahead and finish this up, see what you did. B, what is the probability that Jenna doesn't buy any bananas? Well, you can see my 0 column there, and that is actually a 0.1 or 1/10 or 10% chance that she will come home with no bananas. C, what is the probability that Jenna buys more than 3 bananas? So more than is going to include more than 1 column here. And you can see those 2 columns there, the 4 and the 5. 3 is not included because it is not more than 3. It is exactly 3, okay? So we just pay attention to the 4 and 5 column. And what we have to do there is we have to add them up. And this is somewhere where maybe you might have tripped up, okay? So the probability that she buys more than 3 bananas is the sum of 4 and 5, because she could either buy 4 or buy 5 and still fill that criteria, okay? So 0.2 plus 0.3 equals 0.5, 5/10 or 50%. Okay, what is the probability that Jenna buys at least 3 bananas? So we're looking at how vocabulary affects what we look at and what we do. At least 5 bananas, well, it's going to include 3 bananas now, okay, because 3 bananas is at least 3. Okay, 0, 1, and 2 are not included because they are not at least 3. If we add all of those up, we get 0.7 or 7/10 or 70%. So there's a 70% probability Jenna's coming home with at least 3 bananas. Last one here is, what is the probability that Jenna doesn't buy exactly 3 bananas? Well, we can look at that two different ways. We could add 0, 1, 2, 4, and 5, or this is something we're going to see as a shortcut, and actually it's explained down at the bottom there. We could just do 1.0, which is a whole, minus 0.2, which is the probability of exactly 3. And that leaves us with 0.8 or 8/10 or 80%. Okay, and you'll see down here at the bottom, they go ahead and explain that. You notice that the sum of the probabilities in the table is 1 whole. You know, in a perfect world, that is what it should be. Okay, because a certain number of things can happen, and they each have a probability assigned to them. All right. So in this table up here, if you add the 0, 1, 2, 3, 4, and 5 columns, you would get 1 whole, which is equal to 100%. Okay. So this is always true. When we add up the probabilities of all possible outcomes, the result is always 1. And again, in the future, you may see that 99.9, and a lot of that has to do with rounding choices we make. Okay, so that might not always be the case perfectly, but yeah, but in problems like this, it is. So taking 1 and then subtracting the probability of a given event gives us the probability of that thing not occurring. Okay, so in this case, the chance of exactly 3 bananas being bought is 1, which is the whole, minus the 0.2, 2/10, which is the chance of the 3 exactly, and that gives us an 80%. So there's an 80% chance that she comes home with an amount other than 3 bananas. All right. Okay, so next, here we're still sticking with Jenna. Jenna has a husband, her husband Rick, okay, and Rick is concerned about his diet, all right. On any given day, he eats 0, 1, 2, 3, or 4 servings of fruit and vegetables. The probabilities are given in the table below. Okay, I've pointed to that or, okay, because he'll do either one or the other. Okay, he will not do 2 of those together. Okay, so we're talking about that word or still. All right. So on a given day, find the probability that Rick eats. We'll start with 2 servings of fruits and vegetables. Now this is very easy, of course. It's just taking a number out of that column there. But I'm going to go ahead and have you do those yourself. If you would go ahead and do 1A, B, C, and then do number 2, and come on back and we'll check them. Okay, I'm pretty certain you didn't have any difficulty with this. So let's go ahead and check 2 servings of fruit and vegetables. What's the probability there? Of course, it's 0.28 or 28%. I know the answer guide in my my teacher packet here just leaves it at 0.28. Not quite sure why, because these are always going to be equivalent. So I like 28% myself, but I think in some statistical applications, 0.28 is more usable, I think. But for us, either of those is equivalent. 0.28, or that would be 28 hundredths, or 28%. Okay, more than 2 servings of fruit and vegetables. Okay, we're looking at 3 and 4 columns, and if we add those up, we get 0.51, 51 hundredths, or 51%. At least 2 servings, and that is going to be 2, 3, and 4. This is very similar to what we just saw, and I just went ahead and added that 28%, which is the 2, and the 51%, which I had already added up here. Okay, little shortcut. So 79% or 0.79. And then finally here, find the probability that Rick does not eat exactly 2 servings. This is what we talked about at the end of that last exercise. And that, of course, was 1.0, or 1 whole, 100%, minus 0.28, 28%, and we get 0.272, or 72%. So there's a 72% chance that Rick does not eat exactly 2 servings. Okay, so we did that one up top there already. Here's example 2. Oh wait, here we go. Yeah, it's just so we're going. This example 2 now is going to be the same concepts, same ideas, but now with our beloved. Yes, we love them. Fractions. Okay, our beloved fractions, which take a little bit extra work, but well worth it, and to keep up our practice with fractions. Okay. Now we have Luis, who works in an office, and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and their probabilities are given in the table below. Okay, and this might make a little bit more sense than the whole banana thing, because I'm sure they have lots and lots of data about phone calls and how much time that takes, etc., etc. But anyway, here we go. So we have number of phone calls and then the probability. Now, of course, these are all, again, going to equal up to 1 whole, okay? But they, of course, are in different fractions. All those fractions, you will notice, are in lowest terms already, okay? And you can imagine what is going to be part of our assignment in this example. Okay, so go ahead and find the probability that Luis receives 3 or 4 phone calls. Okay, 3 or 4 phone calls. So let's go ahead and take a look at this one together, and then you can do the rest by yourself that we can check. All right, so receives 3 or 4. Okay, so either one of those can happen. So we are going to add their probabilities. All right, 1/3 plus 1/9. Of course, can't do it as that. So we have to go ahead and get a common denominator, and hopefully by now, 3/9 just pops into your head immediately as being equivalent to 1/3, and then we would have a probability of 4/9 that he receives 3 or 4 phone calls. Okay, so here in the same vein, would you go ahead and do these 3, B, C, and D, and come on back and we'll check in. Okay, so B, find the probability that Luis receives fewer than 2 phone calls. And that would have been 1/6 plus 1/6 equals 2/6, which equals 1/3. Some of you may have shortcutted that right to the end and right to the 1/3 right away. And I sure do hope that is the case for most, if not all of you. All right, next was find the probability that Luis receives 2 or fewer phone calls. And that was 2/9 plus 1/6 plus 1/6. This looks like 7/6 here, but it's not. It's actually 1/6. Okay, so 2/9 plus 1/6 plus 1/6 equals 4/18 plus 3/18 plus 3/18, which equals 10/18, which equals 5/9. Okay, and you might have done it a different way. You might have just taken the made everything into I don't know what you would have done otherwise. But you could have. I mean, you could have made that into 2/6 first, and then just gone from there. That would have been 6/18. And yeah. Anywho, there you go, 5/9. Now we have the probability that Luis does not receive 4 phone calls. Here we go. Same idea as before. We take our 1 whole, take away 1/9, because that 1/9 is the probability of getting 4 phone calls, and then we are left with 8/9 probability of not receiving 4 phone calls. Okay, so hopefully this is going along real smoothly for you. I'm thinking it is. Before we get into some more advanced material, this is a good way to start. I like it. Hopefully you are having the same level of joy as I am. Anyway, here we go with Jenna. We're back with Jenna. When Jenna goes to the farmer's market, she also usually buys some broccoli, okay? The possible number of heads of broccoli that she buys, and the probabilities are given in the table below. Again, more weirdness, but we can still use these numbers. Here we go, and so go ahead. Actually, why don't we just have you go ahead and do that. Use these number of heads of broccoli and their probabilities, and complete A, B, C, and D, and come back, and we will see that you got 100% on that. Okay, so let's check in. That first one was buys exactly 3 heads of broccoli. Of course, that's 1/4, or 1 out of 4, or 25%. Okay, we'll just keep it with fractions right now, though. Okay, does not. So what's the probabilities that Jenna does not buy exactly 3 heads of broccoli? And that was our 1 whole minus our 1/4 chance equals 3/4, 3/4, 3 out of 4 chance, or probability that she does not buy a head of broccoli. 3 heads of broccoli. C says buys more than 1 head of broccoli. Okay, that could be 2, 3, or 4. Add up those fractions, 5/12, 1/4, 1/12. We get 9/12, which is also 3/4. So a 3/4, or 3 out of 4 probability of 1 head of broccoli, more than 1 head of broccoli, sorry. And then buys at least 3 heads of broccoli, and that would be 3 and 4. And those fractions are 1/4 and 1/12, which equal 3/12 plus 1/12, which equals 4/12, which equals 1/3. Okay? And again, this is something that I could do in my head by now without going through all those steps. Hopefully some of you are the same. But if you're not, take your time and just be very, very efficient and thorough. All right, here we go. We are to a diagram of a spinner, and this spinner here is designed like the face of a clock, and the sectors of the spinner are colored red, blue, green, and yellow. Okay, green and yellow. Take a look at that spinner. It's kind of a neat little spinner. And so writing your answers as fractions in lowest terms. Okay, so be very specific. Put these in lowest terms. Find the probability that the pointer stops in the following colors. Red, I am putting 12 in my denominator because, or my initial denominator, because there are 12 equal sections that divide the clock, or divide the clock-like spinner. Okay, so I'm going to have 12 as my denominator, my initial denominator throughout this lesson. And if I look at my red, yikes, I did blue fast too. I forgot to put a stop in. Anyway, yeah, so red was, of course, one of those sections out of 12. Blue, you see there are 2 of those sections out of 12, which is also 1/6 because we are using lowest terms. Okay. Green, putting it out of hand here with green. Green, again, we're looking at 5/12. Okay, 5 of those sections are green. Yellow, we have 4/12, which is also 1/3. So here are our 3 answers: 1/12, 1/6, 5/12, 1/3. Now, if we were to go ahead and check, we could check to see if we've done everything correctly. I have 1/12 plus 1/6, which is 2/12, plus 5/12, which is 5/12, plus 1/3, which is 4/12. We see that there. Okay, and if we add those up, 4, 9, 11, 12 equals 12/12, which equals 1. Okay, so we know that we have accounted for the entire clock-faced spinner. All right, here we go. Complete the table of the properties below. Okay, so probabilities below. Just go ahead and fill that in with what we just did. And if we did, we go ahead and do that. 1/12, 1/6, 5/12, 1/3, correspondingly for red, blue, green, yellow probability. Okay, and then let's answer some last questions, and then we'll be able to close this session, this lesson. All right, so find the probability that the pointer stops in either the blue region or the green region. Okay, do that one, complete that one. Do 7, come on back, we will look at them over, and then we will move on to the closing. Okay, so we're back here. The first was number 6, find the probability that the pointer stops in either the blue region or the green region. And we can see that those chances were 1/6 and 5/12, which is 2/12 plus 5/12, which is 7/12. Okay, so that probability of either one of those happening was 7/12. And now we have the does not stop in the green region, that probability. Of course, we take our 1, which is our 1 whole, 100%, minus our 5/12 probability of green, and we're left with 7/12 probability of anything but green. Okay? Yeah, I think pretty straightforward. Any questions, of course, call me anytime. All right, here's our lesson summary. I had a little trouble with this lesson summary. It's just kind of strange. I don't know. I almost thought of just leaving it out, but let's just talk about it. Okay, so here they're telling us that in a probability experiment where the outcomes are not known to be equally likely, the formula for the probability of an event does not necessarily apply. Okay, and this is the one when they were equally likely. Okay, so in that case, we had the number of outcomes in the event, all right, over the number of outcomes in the sample space. And again, the sample space were the possibilities. And remember, again, if we had 4 colors, all the same probability, we'd have 4 possible outcomes. Okay, that's our sample space, and one of those colors, let's say blue, would be one of those. So blue, and an equally likely, let's say blue, red, green. We've done this so many times now. Yellow, they would all have that 1/4. So this would apply here. Okay, now I'm not sure why they need to kind of distinguish at this point that this is no longer good, because the truth is you're going to be able to use this this whole formula again. Okay, it's just your number of your events and your sample space is going to change a little bit. Okay, and they're trying to give you an example down here of where it would not work. To find the probability that a score is greater than 3, add the probabilities of all the scores that are greater than 3. Okay, so then you're going to use that to find your probability. Okay, to find the probability of not getting 3, getting a score of 3, calculate 1 minus the probability of getting 3. And these are things that we did. And again, I think at this point, I think you understand what I have a really strong sense that you understand what we've just done in this past lesson. I don't think this lesson summary helps at all, because it just seems a little muddled and muddy. So if you want to ignore it, you can. But just to know that we are talking now and into the future about events where outcomes are not equally likely. Okay? Alrighty. Good luck on the problem set, and see you soon.